ACA-Ali, lecturer in physics, and today we want to study about second year physics. The topic of our discussion is from the first chapter, first topic, the very beginning topic, that is Coulombs Law. Also you can call it law of electrostatics. As we are well familiar with the term electrostatics, that is the name of the electro means electric charge, and statics, static is from the word stationary, that is rest. So in this chapter, that is electrostatics, we study electric charges in state of rest. So the topic of our discussion is Coulombs Law. Although we know that, so let's start. Okay, the topic of our discussion is Coulombs Law. Although we know that there are two types of charges, positive and negative charges, and there exists a force of attraction or repulsion between them. From the very beginning classes, we are very much familiar with these forces, but Coulomb is the first scientist who have explained the forces between the charges in very brief manner. Let us start our lecture, that is the Coulombs Law. Okay. What is the statement of that law? According to the Coulombs Law, you can say that the force of attraction or repulsion between 2 point charges, that is the force of attraction or repulsion between 2 point charges is directly proportional to product of magnitude of the charges and inversely proportional to the square of distance between them. So that is the statement of Coulombs Law. As you can see, that is the force of attraction or repulsion between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of distance between them. Let us consider 2 point charges. The first charge is Q1. You know that the symbol of the charge is Q. So we will represent the one charge that is having a symbol Q1. We have another point charge whose symbol is Q2. There is a question that might arise in your mind, that what is point charge? So I will write the definition of the point charge. Point charges are those charges. Point charges are those charges whose size is very small, as compared to the distance between them. That is the point charges. You can see the size of the charges is very small, that is in micrometer, whereas the distance between them is very large. So such type of charges are known as point charges. So according to Coulombs Law, there exists, irrespective to the nature of charge, whether they are positive, whether they are negative, but there exists the force between the charges. That force might be attractive, that force might be repulsive. Okay, so let us consider the charges which are separated at a distance r from each other. According to Coulombs law, what Coulomb law said, let us consider, if you consider the force between them is F, then this force is directly proportional to the product of quantity of charges. Okay, as the quantity of charges increases, the force between the charges also increases. You can call it equation number 1. And second thing is, the second part of the law is this force is inversely proportional to the square of distance between them. Okay, as we increase the distance between the charges, obviously the force between the charges will decrease. So increasing distance decreases force. This means they have inverse relation. So you can write inverse relation as F is inversely proportional to 1 over r square. That is equation number 2. So we have converted the statement of the Coulombs law into the simplest mathematical expression. Okay, now combining the two equations, combining equation 1 and equation number 2, we will get what? We will get F is proportional to Q1 Q2 divided by r square. And we know that whenever in physics we replace sign of proportionality with the sign of equality, you always introduce a symbol of constant, a constant of proportionality. In Coulombs law, we introduce the constant K, Q1 Q2 divided by r square. So you can see this is the simplified form of the Coulombs law. Hopefully you have an idea about the point charges. So I rub this definition. Okay, so I clearly again I write the Coulombs law, its simplest formula as F is equals to K Q1 Q2 divided by r square. And we will name it as equation number A. Okay. So according to the statement, we know each and everything present in this formula, okay, that the force of attraction and repulsion is directly proportional to the product of the quantity of the charges and inversely proportional to the square of distance between them. But what is this K? As we have utilized conventional method, K, it is constant of proportionality. But we want to understand what is the concept of that constant of proportionality. What is the meaning of that constant of proportionality? So if you look at this equation, we want to understand about the constant of proportionality. So here K is constant of proportionality, okay, and its value depends on, here K is constant of proportionality, and its value depends on what? Depends on two factors. Number one, the first thing on which the value of K depends is, if you look at this equation, K depends on each and everything present in this equation. Means K depends on force, K also depends on the distance between the charges, that is r, and K also depends on the magnitude of the charges. So number one, K depends on system of units in which we measure. K depends on system of units in which we measure force, Q, charge, and R, distance between the charges. And obviously, for example, I will take an example of value of G. If you consider value of G, its value in SI system is 9.81 meter per second square. Though it is a constant of proportionality, but when we change the system of units, for example, instead of SI units, if we use say series system, in the series system, the value in which the length is measured not in meters, it is measured in centimeter, mass in gram, and time obviously in second. So then instead of 9 9.81, its value is 981 centimeter per second square. This is a huge difference. So you can see that the value of the constant depends on system of units. Just like similarly, the value of k depends on the system of units in which force, charge and distance is measured. Okay. So the first point, k depends on the system of units in which we measure F, Q and R, and the second and the most important thing is medium between the charges. For example, if we place the plastic between the charges, if we place rubber between the charges, if we place glass between the charges, obviously the force between the charges will be affected. So the second point on which k depends is, okay, that point is medium between the charges. Medium between charges. Okay. So considering these 2 points in your mind, you can say that if I say if we use SI units according to point 1, if we use SI units for what? For measurements of F, Q and R, that is we use Newton for the measurement of force, Coulomb for the measurement of the charge and meter for the measurement of the distance, that is the distance between the charges. Okay, if we use SI units for the measurement of F, Q and R and medium between charges is free space. What does free space means? Free space means that we use medium, that is a free space, that is vacuum or air. The free space means the medium between the charges is either vacuum or you can say also air. Not a big difference between them. Okay, so for the free space, that is if the medium between the charges is free space, means vacuum, nothing is present, no material medium is present between the charges, or you can say that the medium between the charges is air. Okay, then value of k will be equals to what under these two conditions? Then k is equals to 1 over 4 pi epsilon naught. Keep this fact in mind, that this value of the k is when these two conditions are applied. That is the medium between the charges is free space and we use SI system for the measurement of F, Q and R. Then the k is equals to this. Here is a very important thing, that is epsilon naught. It's a Greek word, epsilon. You will not read it as E, it is epsilon. Okay, epsilon naught, it is named as permittivity of free space. Permittivity of free space. Again, the free space, the meaning remains same, whether the medium between the charges is vacuum or air. Okay, permittivity of free space, its value for free space means air or vacuum is 8.85 into 10 raised to the power minus 12 Coulomb square per Newton meter square. You have to keep memorizing this value and keep again this thing in mind that this constant is for free space. If you change the medium, then you will not use epsilon naught. Okay, in that case you will use relative permittivity, which we will discuss later on. Okay, so this is the value of permittivity of free space. Okay, if you use this epsilon naught in the above equation here, you will get what? K is equals to 9 into 10 raised to the power 9 Newton meter square per Coulomb square. So this is the value of the k, constant of proportionality, which we have used in equation A. So we can write equation A, that is a complete form of the Coulombs law. Again, this is a complete form when the medium between the charges is free space, that is vacuum or air. You can write it as 1 over 4 pi epsilon naught Q1 Q2 divided by R square. And one thing will be sure, that is I will write here in subscript form. VAC, that stands for vacuum. Okay, this is the formula valid for the Coulombs law when the medium between the charges is free space, that is either vacuum or air. So that's why I write F vacuum. Along with F, I will use the subscript VAC, that is a shorter form of the word vacuum. So electrostatic force between the charges, when the medium between the charges is vacuum, then you can write it as F vacuum 1/4 pi epsilon naught Q1 Q2 divided by R square. I will write it as equation number B. Now a big question arises that instead of vacuum, means instead of vacuum or air, if we use certain insulating medium between the charges, then what will be the effect of this medium on the forces between the charges? So if you place some insulating medium, say rubber or plastic or glass or any insulating medium between the charges, then the force of attraction or repulsion will decreases. Keep this thing in your mind. When you place certain insulating medium between the charges, then the forces between the charges will decrease. Okay, then how you can write equation B? I must have to write a sentence for this. Along with the journal heading, that is Coulombs law. Coulombs law for material medium. Coulombs law for material medium. Okay, so one thing, that is, if we place certain insulating medium between charges, then electrostatic force. If we place certain insulating medium between charges, then the electrostatic again, the force between the charges when the charge is in the state of rest, as in accordance with the name of the chapter. Okay, if we place certain insulating medium between the charges, then the electrostatic force, what happened with the electrostatic force? Electrostatic force will decrease by factor. How much? By factor epsilon r, known as relative permittivity. What does relative permittivity means? Now hopefully you can understand that term, relative permittivity. That is, if we place an insulating medium between the charges, then the force of attraction or repulsion will decrease by the amount epsilon r. So you can write the Coulombs law in this form, that is F. Now instead of vacuum, we will write it as F medium. The formula can be written as 1/4 pi epsilon naught epsilon r. Along with epsilon naught, we have introduced another constant, that is epsilon r, relative permittivity, that shows the quantity of force that is decreased by placing an insulating medium between the charges. Okay, you can see it have inverse relation with the force. Okay, so it can be written as Q1 Q2, other equation will remain same, R square. So this is another form for the Coulombs law. I will write it as equation number C, another form from the Coulombs law, and this shows the force between the charges when the medium between the charges is certain insulating medium. Okay, So that is the Coulombs law for the free space. You can say equation B, and this is the Coulombs law when the medium between the charges is some insulating medium. Okay. So this is the simplest form of the Coulombs law. Now I will extend my lecture for the vectorial form of the Coulombs law. Now hopefully you have the record of all this lecture. Now I will rub the first initial portion. Hopefully everything written in this portion, it is in your mind. Okay, let's move forward. Now we want to understand vectorial representation of Coulombs law. Vectorial representation of Coulombs law. As we know that the force is a vector quantity, and in order to show the vector quantity, we must have to mention its magnitude as well as direction. So vectorially, first look at this figure. Again, I will draw it in more proper form. Again, consider the first point charge Q1, the second point charge Q2, the distance between them is R. Okay, now there is a point which charge will exert force on which charge, whether charge 1 exerts force on charge 2 or charge 2 exerts force on charge 1. So actually both the forces exerts force on each other. I can write it as F12. What does this F12 means? It is not F12. What does it F12? We can read it as F12, that is, concentrate, force on charge 1 due to 2. F12 means force on charge 1 due to 2. And F21. What does F21 means? Force on charge 2 due to 1. So how we can write it mathematically? Now I'm writing it mathematically. First we can write it as F12. And what is F12? Force on charge 1 due to 2. Good. Okay. So F12, I can write it as that is K, constant of proportionality, Q1, Q2 divided by R square. Along with this, I can write it as the most simplified form, 1, 2 bar. Now what is this? R12 cap. R12 cap. Now here R12 cap, as you studied in first year chapter number 2, the topic is unit vector, a vector which is used to describe the direction of the given vector, a vector whose magnitude is 1 and used to describe the direction of the given vector. So here R12, because I am writing it in vectorial form, so this you can say the magnitude and this shows the direction. That is a complete description of the vector quantity. Okay, so here R12 is a unit vector, R12 is a unit vector used to show direction. Direction of what? Obviously direction of force, direction of F12. So this is another form for the Coulombs law. Okay? But it is represented in vectorial form, that is for the force F12. I will call it as equation C, and then it is equation number D. Now similarly, now you can easily write the force F21, that is force on charge 2 due to charge 1. So F21 can be written as K Q1 Q2 divided by R square into R21 cap. So you can write again here as that here R21 cap is a unit vector, vector used to show what? Used to show direction. Direction of what? Direction of F21. Okay. Hopefully you got it. And we will call it as equation number E. Okay. So now this is the simplest vectorial representation of the Coulombs law. Very simple. Okay. Now at the start I have raised a question that which charge will exert force on which charge? Either Q1 exerts force on Q2 or either Q2 exerts force on Q1. So as I have already cleared that both the forces exerts force on each other and the magnitude of these forces are shown in front of you. Okay, if you look at here, now again I will rub this portion. Hopefully everything present in this portion, it is in your mind. Okay, concentrate on the last portion of our lecture, and that is, okay, if you look at equation number E and D, yeah, I can write it from this figure. Look at this figure. From figure, I can write it as R12 cap is equals to minus R21 cap. As I already mentioned, R12 cap or R21 cap are the unit vectors used to indicate direction. We know that unit vector is a vector whose magnitude is 1. So whether it is R12 or R21, both have same magnitude, but because both are the unit vector, all the unit vectors have a unit magnitude, so they have same magnitude. That's why I have put sign of equality between these two unit vectors. But I have also introduced the minus sign. If you look at this figure, why I have introduced minus sign, then it will be easily understandable for you people that this minus sign shows that the direction of both the forces are opposite to each other. Say in this figure, if one force is towards right, other is towards left. If one is in upward direction, other is in downward direction. So as the direction of both the forces are opposite to each other, that's why we have introduced a minus sign. Hopefully you got it. Okay. Now use this equation in any of the equation, whether in equation number D or equation number E. Okay. I will use it in equation number, say, D. Use in equation D, then you can write it as, look at here, F12 vectorial representation is equals to K Q1 Q2 divided by R square. Now here at the place of R12 cap, we introduce minus R21 cap. Is it so? We have replaced R12 in equation number D with minus R12. That is putting the value of this equation in equation number D. Okay, so it will become this. So it can be written as F12 is equals to minus, we'll bring it the first, K Q1 Q2 divided by R square into R21 cap. Now look at from equation number E. From equation E, look at equation number E. This thing will becomes the form of equation number E. K Q1 Q2 divided by R square into R21 cap. So from equation number E, this whole term will be equals to F21. So what you can write it as F12 vector is equals to minus, instead of this whole thing, you will utilizing what? F21. F21. So we have concluded a very important point. What is this? That is, attractive or repulsive forces between the charges have equal in magnitude but opposite in direction. Their magnitude remains same, but their direction is opposite. whether the charges are positive, negative, positive, any combination, always the magnitude between the forces are equal and all the time they are opposite in direction. Okay, students, this is my first ever lecture here, online lecture. This is the first topic of our second year course, that is the Coulombs Law. In future, inshallah, I will deliver more videos, more lectures, and I will guarantee you that whenever I will teach you any topic, any difficult topic which you feel difficult, inshallah, I will make it simple for you. This is inshallah my guarantee to you people. Okay, thanks. Allah Hafiz.